Since we will be dealing with inequalities, so let's talk about properties of inequalities, and we will try to solve the inequalities. Okay, let us consider a is less than or equals to b is an inequality. Well, the properties that we are going to discuss will also hold for a is greater than b, a is greater than or equals to b, and every kind of inequality. Okay, let a is less than or equals to b is an inequality and c is any real number. Okay. Now the first property is about sum or addition property. Sum property or addition property. So it says that if we add same real number to both sides of the inequality, then the inequality does not change. We are able to, or we should be able to add same numbers in both sides of the inequality. And multiplication property says that there are two things to consider for multiplication property. One is if we multiply a positive number, okay, on both sides where c is a positive number, then the inequality remains intact. There is no change in inequality. However, if we multiply an inequality by a negative number on both sides, the inequality reverses. That means it will be greater than or equals to. So less than or equals to changes into greater than or equals to. Okay. So this is the key difference between solving an linear inequality and solving an equation. And also multiplication also means division. Dividing both sides of an inequality by a negative number will reverse the inequality. Okay, so to use the properties that we have mentioned a little while ago, let us solve this inequality. Negative 3 by 4x is greater than or equals to negative 5 over 8 plus 2 by 3x. So first of all, what I would like to do is I would try to get rid of the denominators. Okay. To do that, let me multiply both sides by 8 at first, right? So let me multiply both sides by 8. So that means this will give us 8 times negative 3 over 4x is greater than or equals to 8 times negative 5 over 8 plus 8 times 2 over 3x. Okay, multiplying both sides by 8. Since we want to get rid of the largest denominator, okay, then you can see 4 times 2 is 8, 8 and 8 cancels out, and this becomes 16x. Okay, 16x over 3. So then I can write, I hope this thing is clear for you, since we are multiplying by 8, which is a positive number, so this inequality remains intact. Nothing changes. So 2 times negative 3 is negative 6x is greater than or equals negative 5 plus 8 times 2 is 16 divided by 3x. Then I would like to get rid of 3. Multiply both sides by 3. Okay, so that means I can write this as 3 times negative 6x is greater than or equals to 3 times negative 5 plus 3 times 16 over 3. Then you can see 3 times negative 6x would be negative 18x is greater than or equals 3 times negative 5 is negative 15. And this is 3 and 3 cancels out. So that's 16x. Alright. So we have successfully removed all the denominators. Now it's slightly easier to calculate. Okay. And here also, since 3 is a positive number, so multiplying an inequality by a positive number won't change the inequality sign. Now let us gather the like terms in one side. So let us subtract 16 from both sides. Okay, let us subtract 16 from both sides, means negative 16x negative 16x. Okay, so the quantity of x is in the left hand side. Then we will be getting this kind of situation. Then we will have negative 18 minus 16x in the left hand side, which is 34. Negative 34x is greater than or equals to negative 15. Okay, so that's fine. Now, since we have isolated the term involving x in one side and constant in another side, so let us do the multiplication. So let us multiply both sides by negative 34. Okay, then we know that since we are dividing both sides by negative numbers, so our inequality sign should be reversed. Then here 34, negative 34, positive 34 cancels out. So x is less than or equals to negative negative cancels out, 15 over 34. So that would be our result after we have divided both sides by negative number. Okay, look here, we have reversed the inequality sign after dividing by negative 34. So be careful. So can we reduce this fraction into its lowest term? I think no. No, we can't do that. So this is our answer. And let us write this answer in other ways also. By using interval notation, we can simply write 15 over 34. And since x is less than 15 over 34, so we are considering every number which is less than 15 over 34. So that's why we put a square bracket in here, since we have equality sign. And then it goes towards left hand side. That means we will have negative infinity in here. So everything is less than 15 over 34. So that's the interval notation. Now, for the graph, we can just write this as 15 over 34 is less than 1. So let's suppose this is 1, this is 0, and this is negative 1, and so on. Then you can see that 15 is slightly lesser than half of 34. So we might want to think this is half. And so this would be the place, tentative place where we have 15 over 34. And it will go in this way. So this is the solution of this inequality. Let's talk about slightly advanced version of inequality, which is known as compound inequalities. This kind of inequality, which is combination of two inequalities. One is this one, 3y is less than 4 minus 5y. And another inequality is 4 minus 5y is less than 5 plus 3y. That's another inequality. So if we combine them, then that becomes a compound inequality. Okay? And solving this inequality is not that hard. Okay? It uses or employs the same properties that we have already seen. Okay? And we should do the same operation on all these three parts if we want to change anything in one part, either this left part, middle part, or the right. The goal for solving this inequality is to make the variable alone in the middle part. Okay? So we try to make the variable alone in the middle part. So here, let us solve this. Try to get rid of this 4 from the middle part. So let us subtract 4 from the middle part. Then you should do the same operation on all three parts, left, middle, and right. So negative 4 here, and here also negative 4. The left part will be changed into negative 4 plus 3y. These two will be gone. Negative 5y is there. Less than 5 minus 4 is 1 plus 3y. Okay, so we have gotten rid of the constant term in middle part. Now, since the left hand side and right hand side also has the y variable, okay, the terms involving y variable. So we want to get rid of the terms involving y variable in left and right part. So we add negative 3y on all sides. Okay. Negative 3y in here, negative 3y in the right hand side, and negative 3y in here. Then you can see that 3y, negative 3y cancels out. Here also it cancels out in the left and right hand side. Then this will turn out to be negative 4 is less than negative 5, negative 3 is negative 8, y is less than 1. Now we want to get rid of this negative 8 from the middle term. Okay, so let us divide all sides by negative 8. So this would be negative divided by negative 8, negative 8, negative 8. Okay. Then this inequality, this compound inequality will change in this form. Okay. So negative 4 over negative 8 would be negative negative cancels out. 4 times 2 is 8. So that would be 1 over 2. And middle term, it will be negative 8 cancels out. So that's y and 1 over negative 8. Or simply we can write negative 1 over 8. Now, since we divided all three sides by negative number, so we need to reverse the inequality sign. So let us reverse this less than or equal, less than, it will be greater than sign. So this would be our inequality, compound inequality. You can flip these two and write in this way: negative 1 over 8 is less than y is less than 1/2. All right. Simply you can see that negative 1 over 8 is less than y. Okay. So y is always greater than negative 1 over 8. That means negative 1 over 8 will lie in the left hand side of y. And similarly, 1 over 2 is greater than y means 1/2 will lie in the right hand side of y. So that's why we can write in this way. So this is one solution. Another solution would be to write in interval notation. So the interval notation would be negative 1 over 8 would be the left endpoint, since that's strict less than, so that's why we go for parenthesis, left parenthesis, comma 1/2. It is strict, so that's why we go for 1/2. Right? So this is our interval notation answer for this compound inequality. And finally, the graph would be something just like this. Let's suppose this is 0 and this is 1. Okay, this is 1. So 1/2 would be somewhere here, and negative 1/8 would be somewhere here. Graph would be something just like this, parenthesis here. Okay, and this would be our solution set. So that's how we deal with compound inequalities. Let's talk about absolute value inequality. So before solving any absolute value inequality, we need to define what is an absolute value, and let us review what is an absolute value. So number one, absolute value of a number x, of a real number x, is defined as x itself, only the numerical value, if x is greater than or equals to 0. And negative x, that means if this quantity is negative, then make it positive. Okay? So if x is less than 0. Okay? So remember this definition of absolute value. We'll be using that in the exact way which we are seeing here. Now the second note would be number 2. Second note is if x is less than or equals to a, for a is greater than 0, negative a is less than or equals to x is less than or equals to positive a. That's what we need to understand. If x is absolute value of x is less than or equals to a, for a greater than 0, then negative a is less than or equals to x is less than or equals to a. Again, if x is greater than or equals to a, where a could be anything, especially a is if x is greater than or equals to a and we don't have any restrictions for a, right, then either x is less than negative a or x is greater than a. In this situation, the graph would be something just like this, and in this situation the graph would be something just like this one. Let's take an example of absolute value inequality. Absolute value of 2x plus 1 plus 1 is less than or equals to 6. Here, now let us try to transform this equation, this inequality into this form. Okay, so let us add positive 1, negative 1 on both sides. So that means we'll be getting 2x plus 1 is less than or equals to 5. Okay, now we got our inequality in this form. Then this can be written as negative a is less than or equals to x is less than or equals to a. Okay, so let us write in this way. So a is 5, then I can write this as negative 5 since a is 5, so I can write this as negative 5 is less than or equals to 2x plus 1 is less than or equals to 5. Okay, since instead of x we have 2x plus 1, so that goes in the middle. Okay, now since we want to get rid of any constants in the middle, so let us subtract 1 from all sides, from left, middle and right. Then we'll be getting negative 5, negative 1, that's negative 6 is less than or equals to 2x plus 1 minus 1, so that's simply 2x is less than or equals to 5 minus 1 is 4. Okay, all right, now we need to get rid of this 2 which is in multiplication with x in the middle part. So let us divide this by 2, the middle part by 2. Then you should do the same operation for left part and right part also. Then you will be getting negative 6 by 2 is negative 3 less than or equals to 2 and 2 cancels out, remaining is x. 4 by 2 is simply 2. So that's our solution. That's our solution. Now let us write this solution in interval notation. So that would be negative 3 and 2. They are the endpoints, left endpoint and right endpoints. Negative 3 is included, so put a square bracket. 2 is also included, put a square bracket. And for the graph, let's suppose this is 0, 1, 2, 3, negative 1, negative 2, negative 4 and so on. Since negative 3 is included, so we write in this way, and 2 is also included, so we write in this way. So this is our interval notation or graph of the interval notation.